Good morning, everyone. I'm going to start with a story. In the 1930s, the London Underground had a problem. The network was expanding, but people were struggling to use it. Now, the problem was the maps. They were geographically correct, but they weren't useful. They had things, correct distances, correct locations, but they were impossible to understand. A draftsman called Harry Beck, he decided to do something different. And he focused on what was needed. So he looked at using sequence, what connects to what, relative scale. The result was the tube map that we use today. Not perfect, but useful. Subsea digital twins face exactly the same challenge today. I'm Tom. I'm a principal product manager at Aize, and at Aize we build digital twin technology. So I'm really quite pleased to follow Jan, actually. We're same space, similar messages, actually. Our experiences on both topside, subsea, and onshore are all pointing towards a very common goal: making complex asset data useful. I've got experience with TotalEnergies in a previous life, working as a drilling engineer, and I lived those problems. Today I'm going to talk to you a bit about the lessons that we've seen on how to get started with digital twins. Let's get to that one. Everyone's talking about digital twins. There's genuine interest for a good reason, be it intervention planning, campaign management, work orders. But what we see is, while ambition is there, the first step often isn't clear. And that can result in failure to even get started or getting bogged down in even just getting going and unlocking any value. Some initiatives try to start with everything at once. Let's throw it all in, see what we get. Others start with a pilot that never really goes anywhere, grinds to a halt. So the real challenge that we believe is it's not why you should build a subsea digital twin, it's how you should get started to move on. And when we talk about getting started, we're not talking about a big digital transformation program. We're talking about going from an idea to something that is actually useful. And it usually starts with a very practical decision. Could a digital twin help me make this decision better or faster? And from there you build the foundations that you need to answer that decision. Very quickly you move from that idea through to a functioning twin. Not perfect, but useful. Now, the same operators we speak to have lofty ambitions. AI, automation, integration, lots of sexy buzzwords, lots of cool stuff, no doubting the value in it, no doubting the ambition. But a lot of them fail because there's nothing underneath them. There's no substance. You need the foundation. Advanced use cases don't fail because of lack of value, lack of ambition. They fail because of lack of foundation. And the good news is, I put to you, is that those foundations don't need to be heavy, but they do need to come first. And we'll talk through some of those now. So lesson one in getting started, as far as we're concerned, is creating a contextualized 3D scene. Now, I call this a lesson deliberately because a lot of people think they already have it. You've got some field layouts, you've got some models, you've got some drawings. That's all great. But what's missing is a single 3D view that gives a trusted visual source that teams can actually work with. In a contextualized 3D view, those aren't just shapes. That cylinder is not just a cylinder. That cylinder is tagged and identified. It's a subsea control module. It has engineering data, and it's in the right place. It's useful. What turns that 3D model into a visual reference is that trust. People can use it. It's the foundation to do anything beyond that. So you've got your foundations. And it's worth saying, actually, before we even jump into this, if you don't have 3D models, there's other ways to go about that. We've heard an excellent presentation there from Jan about reality capture, subsea scans. Operators, go to your contractors, do they have original models? Do they have close enough models? Because what you're not looking for is perfection. What you're looking for is a guide, a relative foundation you can get started with. And we see scans actually providing that a lot of the time. That can be the foundation. But in terms of the data, make it meaningful. The data I'm going to talk about is already available. Let's say anomalies, inspection findings, time series data, all available, but in source systems. Those source systems are more often than not totally siloed, disconnected from anything else. And it's the relationship with other data that matters. So an anomaly, for example, can be related to a tag. That's great. But when that tag is related to an object in 3D space, then the visual representation is there. It's visible in its spatial context. Nothing new has been created, but what it allows engineers to do is at a glance to make sense of what they're looking at. It's not just something in a list, something on a dashboard. It's something they can understand, they can relate to, they can assess. This is where teams really start to take value. They can take insights. They're not just looking at data for the sake of data. And I'll make this clear or ground this with a bit of a concrete example. An operator that we've been working with, about 18 months ago, they were performing an RV campaign. And some of the RV operators who were using Aize, they shared some feedback that actually where they were operating, water depth and the conditions meant that visibility was particularly poor, which is not that unusual. So actually they were able to pull up the twin and see the right 3D context of what they were working with. They were able to understand orientation, understand location of what they were looking to inspect, and actually take decisions much faster. The result was exactly that. They were able to reduce the number of clarification loops. They were able to be much more focused on what they were doing. And actually, they were able to save time on the mission. DSV utilization reduced. That's where the real value works. And that value came from context, not from complexity. The third lesson is around about what you do once you've got that data in there. Now, we see it all the time. Strong tendency, I've got a twin, I've got some data in it. Let's chuck everything else in there. Let's get this time series, let's throw it in there. Let's get every bit of data that we possibly want to use. Let's throw it all in there. It must be useful. You often get bogged down, though. That can really slow things down, and a lot of digital programs grind to a halt at that stage. What you want to be doing, and what we see success with customers in doing, is taking one decision and pulling in what you need for that. Let's say your objective is to improve your intervention planning. You've got your foundation, pull in the data that's relevant. Pull in your inspection plan, pull in that data, pull in your anomalies, and leave it at that. Start with that value, start with that decision, and let that pull in. This is how your digital twin stays useful and avoids becoming bogged down and becoming overwhelming. And we see this time and time again. Now, I think it's worth, at this stage, just talking about collaboration, actually, because operators, you don't have to go this alone. It's worth adding that where we see success is where roles are clean. Operator, own the problem, define the value, and lead at that level. Let specialists do the heavy lifting. Cleaning prioritized data sets, capturing and processing subsea scans, managing your integrity data. That's what they're good at. And then work with digital twin providers, like Aize, to make that data available, provide a visualization that is useful. When those roles are clearly defined and that collaboration works well, echoing what Michael was saying about collaboration, that's when you can really start to move quickly and get to value quickly. And if you are thinking about getting started, I think being realistic about what success looks like in the first year is really important. It definitely does not look like a fully complete, perfect digital twin. And it doesn't look like every single data source connected. What it looks like is a trusted visual reference that people can actually use. It looks like teams using that to take better informed decisions and make those decisions faster. And you've built a foundation that you can then deliberately expand on when the value and the use cases dictate that you should. So I'm going to finish where I started off. The problem with subsea digital twins is not whether you should have one, it's about how you should get started. Jan alluded to there are many definitions on what a twin is, but our recommendation and our experience would be start with a focused decision. Start with what you want to, where you want to move the needle. Use that to build the context and guide what data you bring in next. Thank you.